Alright, if you were absent, here is the discussion for chapter 1, 1.1 and 1.2 from your textbook. So 1.1 is pretty much straightforward. It's about measurements and estimates. Measurements basically help us compare objects and understand how they relate to each other. It does require approximating. Smaller measuring units can give more accurate measurements. So when you are measuring something and say for instance you want to measure something to a more smaller value, then that will give you a more accurate measurement. That will make more sense as we go through more examples later on. And then of course, when you're measuring, you have to make sure that you're selecting first a property of the object that you will be measuring. Then you decide what unit to select and then determine the number of units. Okay, so that's kind of just like background information on what measurements are and how they're done. Now, estimating or estimation is finding an approximation as close as possible to the value of a measurement through sensible guessing. Now, I believe in your textbook, so that phrase or that word sensible guessing is highlighted somewhere, or at least it's mentioned. You have to be familiar with that phrase, what sensible guessing really is. Okay, never mind. It's on page 6 of your textbook, so I'm using the Oxford one. The definition for estimation uses the phrase sensible guessing, so make sure that you're aware of that. You're not just guessing or estimating to any number that you want. It has to make sense. Okay. Now, estimation is done by comparing the attribute that is measured to another one or by sampling. Okay. And that's basically what 1.1 is all about. It's just giving you background information, conceptual understanding on measurements and estimates. Okay. All right, moving on to 1.2. Recording measurements, significant digits, and rounding. You should all have a basic understanding of what this is. Okay, so first of all, decimal places, pretty straightforward. So this is just the number of decimal places after the decimal point, or the number of digits after the decimal point. Okay, so if you're asked to round to 2 decimal places, then you could give me an answer of 0.57. Okay, there are 2 digits after the decimal point, therefore you're rounding to 2 decimal places. Okay, now let's say for example, just as a refresher, my number originally was 0.568. If I'm asked to round to 2 decimal places, then obviously I count up to the second digit and then I look at the digit beside it. Is it more than 5? Is it 5 or more, I should say? In this case, yes. So I have to round this digit up and I will end up here with 0.57. That's rounded to 2 decimal places, as I mentioned earlier. Okay, so that's what decimal places are. Now for significant figures. Now there are several rules for significant figures. If you look at page 8, example 1, there's an example there. It's pretty much straightforward. Okay, it's just the numbers that you count. It's the numbers that are significant, and there shouldn't be any confusion if you don't have zeros. Normally, the confusion arises when there are zeros involved. So if you look at example 1 in your textbooks, that's what I'm looking at right now. Okay, 21.35. Okay, you just count how many digits are there. Okay, and in this case, there are no zeros, so that's easy. You just count 1, 2, 3, 4. Hence, you have 4 significant figures, and we abbreviate that with SF. Okay, similarly, for 1.25, this one has 3 significant figures. Again, 1, 2, 3. We don't really mind the decimal point for this kind of question. Okay. Now, what about if there's a 0 in the middle and there are no decimal places? Okay, because it's sandwiched, I like to say that. Also, if you're taking IB Physics, there is a lesson, an introductory lesson on significant figures too, so there should be overlaps here. You count the 0 because it's in between 2 significant figures. Okay, 3 and 5 are both significant. 0 is sandwiched between them, and therefore we have 3 significant figures for this one as well. Okay, now if you look at 1009, same rule applies. Okay, here, both 1 and 9 are significant. The zeros are sandwiched, hence you count them. So you should have 4 significant figures. Okay, now what if you start off your digits with zeros? As such, again, this is still on example 1. Okay, you don't start counting what's significant until you reach a non-zero number. So you start counting here. Okay, 3 is significant, and then the zeros after 3 also become significant. Okay, hence in this case, you should have 3 significant figures. Alright, now for the last one given here, 0.002. Okay, there should only be 1 significant figure, because again, you don't start counting. If you begin with zeros, you don't count them. You only start once you reach a non-zero number, which in this case is 2. Hence, we have 1 significant figure. I'll be uploading another video for the next examples. So far, this is what 1.1 and the first part of 1.2 is all about.